Dear students, today's topic is potentiometer. All of you have heard about the resistor. Resistors are used to resist the current flow through a electric circuit. And all of you have seen the fixed resistors where the resistance value is fixed. Another type of resistor is also available in the market, which is potentiometer or variable resistor. Potentiometer is also known as a pot or pot meter. A potentiometer is basically a three-terminal variable resistor and it is used to control the flow of electric current by adjusting resistance. Now, there are two types of potentiometers are available. First one is linear potentiometer and another one is circular potentiometer. Here I am showing you the symbols of these two types of potentiometer. This is the symbol for linear potentiometer. You can see there are basically three terminals, terminal 1, 2 and terminal 3. Terminal 1 and terminal 3, these two terminals are the fixed terminal, whereas terminal 2 is the variable terminal. Similarly, for circular potentiometer, this is the symbol. Here also you can see there are three terminals, 1, 2 and 3. Terminal 1 and 3, these are fixed and terminal 2 is the variable. You can see with the terminal 2 there is a knob connected. By varying this knob, you can vary the terminal 2 throughout the length of the resistance. Now, we have to know the working principle of a potentiometer. Now, already I told you that potentiometer work by varying the position of a sliding contact across the uniform resistance. And in a potentiometer, the entire input voltage is applied across the whole length of the resistor. See this diagram, you can see this is a linear potentiometer and here there are three terminal, terminal 1, terminal 3 and this is the terminal 2. Now, terminal 1 and terminal 3, these two are fixed terminal and these two terminals basically connects the total length of the potentiometer, and between these two terminal input voltage is connected, and the output voltage is the voltage drop between the fixed and the sliding contact, which is shown in this diagram. This is the terminal 1, which is a fixed terminal, and this one is the terminal 2, which is a variable terminal or sliding contact, and we have connected a voltmeter to get the reading of the voltage drop, output voltage drop between these two terminals. Now, when you vary this position of this terminal 2, the resistance value is basically varied, and depending on that resistance value, voltage drop will be different, which is measured by this voltmeter. So this is basically the working principle of the potentiometer. Now, how to measure the value of a potentiometer? Various kind of potentiometers are available in the market, like 10K pot. 10K pot means pot value is 10 kilo ohm. 22K pot, that means the pot value is 22 kilo ohm pot. 100K pot, that means 100 kilo ohm pot. Now, if you want to measure the maximum resistance value or the total resistance value of a potentiometer, we can place our multimeter. Here multimeter is the measuring device. You have to place the multimeter terminal in the resistance measurement section. Then multimeter is able to measure your pot value. Now let's consider this is a circular potentiometer. The total length of the potentiometer is divided into resistances R1, R2 and R3. Now if you place your multimeter between these two fixed terminals, that is terminal 1 and terminal 2, the multimeter will measure the total resistance of this pot always. Why? Because terminal 1 and terminal 3, these two fixed terminals are connected at the end of these potentiometers. So total resistance R equals to R1 plus R2 plus R3, and R is the maximum resistance value or the total resistance of the potentiometer. Now if you want to measure the minimum resistance of a potentiometer, then your multimeter, or here it is represented as DMM. DMM means digital multimeter. You have to connect your DMM between terminal 1 either or terminal 3 and the terminal 2. You can connect these two terminals also to measure the minimum resistance. When your DMM is connected between the fixed terminal 1 and sliding terminal 2, then by varying this knob, your variable contact position should be placed at the minimum end towards the terminal 1. Then DMM will measure the minimum resistance value. Why? Because if this is R1, this is R2 and this is R3, then you can see the terminal 2 position is basically placed at the minimum end of the potentiometer, and at this end no resistances like R1, R2 and R3 is connected. So DMM will measure the minimum resistance of the potentiometer. Why I am saying the minimum resistance and that should not be 0 ohm? Because this connecting lead, it has also some resistance value, and that will be shown by the DMM. Maybe it will be 1 ohm to 2 ohm. Now another process, using the terminal 1 or terminal 3 and the sliding contact, which is the terminal 2, using these two terminal or these two terminal, we can measure the maximum value of the potentiometer also. How? Now if you are placing your DMM between terminal 1 and terminal 2, then your sliding contact position should be placed at the maximum end of the potentiometer. Then it is basically connecting R1, R2 and R3, the whole resistances between the terminal 1 and terminal 2, and as your DMM is placed between terminal 1 and terminal 2, so it will measure the maximum value of the potentiometer. So before using a potentiometer, we can verify the actual value of the potentiometer by using the multimeter also. It can measure the actual value of the potentiometer. So for today, it is ended for today's video. Thank you all. Next video will be uploaded very soon.